there. I didn't have it in the file at the time. They've been promoting that for a number of years. The difficulty of the tube blade is that the bearings, because the winds can catch it and you don't have the evenness of the wind on the bearings at the time. So they tend to wear out faster. This is one, the big one there is actually another, I believe this one's GE also. And tube blades is actually more efficient. You know, they'll tell you that, and that's true. The tube blade is more efficient than a three blade as far as using the wind. But that's providing that you're not using all that extra power on the bearings and losing it that way. They typically will go 6 to 100 miles an hour as far as the wind speeds that they'll run to. The ARE that you saw in the previous slide is rated up to 100 miles an hour and still produce power. The big ones typically stop at about 35 to 40 because otherwise they rip apart. You have the option to go with vertical axis ones, and sometimes those are promoted. And in fact, I had talked with a fellow. He stopped in our office a couple months ago or so. He was promoting a vertical axis one. It was a little different than this one. It's actually one that Jay Leno put on one of his buildings. And because the name Jay Leno was associated with it, he thought that was absolutely awesome. I said, well, what's the rating on it? And he didn't have that, but he just knew it was an awesome design. So I found out the company and everything and found the rating on it. Well, at 50 miles an hour, it reaches full potential. Well, we don't have 50-mile-an-hour winds average, and I don't think that they do out there typically either. So while it might produce enough certain times, you know, the reality is it doesn't produce it at the right times. If we go with the AREs or even the Bergies and the Southwest Wind Power, some of those, like you saw in the other ones, they actually produce at much lower wind speeds. The African Wind Power is good. The AREs is better yet. The ARE will actually produce the rated power at about 18 to 20 miles an hour. And that's much better because at 6 miles an hour they start turning, okay? At 7 or 8, they start actually making power that's really usable. You want to have at least 8 miles an hour before you really plan on using the power. It's just not significant enough to even bother with. At 12 miles an hour, which is the average wind speed in our area, then you've got roughly 50% of your power. Going from 12 up to 18, it goes from 50% of your power up to 100% of your power. Well, that's not a very big jump. We have a lot of days we can get 18-mile-an-hour winds in our area. And so we can get to that level. If you go to the Southwest Wind Power and look at theirs, if you go to the SkyStream, which I should have put a picture of those, I'm sorry I didn't have that one, but that's one of the new ones that just came out. If you look at the real test data on those, they've got to be about 28 to 30 miles an hour before they reach their rated output. And you don't think that's a big difference, but it is, because you hardly ever get those winds consistently for more than just an hour at a time. And an hour at a time isn't what you're looking for. You want the long-term consistency. Here's another one just in a test lab. It's kind of neat looking, the kind of yellowish green there. Basically pretty worthless. We did have another manufacturer. Well, he's in the design stage. He thinks he's going to start manufacturing. Stopped at our office last week and wants us to work with them. We haven't actually seen his turbine yet, but he says it's vertical axis, and he says it's twice as efficient as these. So we're apprehensive, but we're anxious to find out what he's actually got. He's supposed to come back in a week or two with that. As far as the noise level, most of them are about the same noise level as surrounding trees nowadays, in that if you have a windy day, you stand out there with the turbine on one side and a tree on the other side, chances are it'll be about the same volume of level. You'll be able to hear the difference. You'll be able to hear the turbine, and you'll be able to hear the trees because they're different frequencies. It's like different frequencies of sound, you know, in your stereo. You can hear the bass, you can hear the treble. It's that kind of difference, but it's the same volume level. There are a few turbines that are noisier. The AirXs are noted for that. If you look on top of the ITC building, I believe that's what it's called over here, there's an AirX running today, and you can hear it from quite a ways away. That's a 400-watt turbine compared to the ARE that I showed you a little while ago that was a 2,500-watt turbine. The 2,500-watt turbines you can stand under in 30-mile-an-hour wind and hardly hear them. This one, the ARE, or excuse me, the ARXs, you can hear winds over 15, but they don't reach their maximum until like 28 miles an hour. So there's a little difference that way. So be careful if you look at the really small ones versus the next size up. Just as a comparison, the larger turbines, and you might have noticed the one that's out here too, the Ventura, I believe it is there. It has a kind of a whooshing sound. You get to that level. And the actual noise levels as far as decibels are in the 50 to 60 decibel range typically, which is kind of speaking level. That's what we're doing here today. If you talk just friend to friend, you're probably in the 45 to 50 range, somewhere in that. To give you a comparison, lawnmowers are in the 80 to 100. Well, you can imagine if your turbine was 80 to 100 and it was running 24 hours a day, your neighbors would be complaining all the time. You would too. You wouldn't want to be inside there. Ours, for example, we hardly ever hear them, even when we stand outside under them with two of them. And extremely rare we can hear them inside the building, even with the windiest conditions. The worst conditions for noise are the extremely gusty conditions, like a storm, where you have this huge blast and nothing, huge blast and nothing. And that's because the wind is not consistently going across that. It's like an airfoil. When it's hitting at one spot, and then so it's starting to speed up, and then it slows down, and it starts to, the wind slows down, the turbine starts to slow down, and it hits it hard again, and speeds up, and that's when they're the noisiest. As far as durability, most turbines now are warranted for at least 5 years. Berge claims theirs to last 35 to 40 years. Same with the AREs. Southwest Wind Power doesn't make that claim. They do warranty them, I think, for 5 years still. So you be careful when you watch for that. And also watch that the blades are warranted too. You want to make sure the blades are warranted along with the head. If they're not, then they're not having much confidence in that. The ARXs, the 400 watt, which is again about 3-foot diameter, they used to recommend that you order a set of blades when you order the turbine because they were breaking them so much. We had it for several years, didn't have any problem. Finally sold it to a school for a demo, and to my knowledge, it's fine there. So maybe they corrected the problem, but that's what they used to say anyway. Life expectancy for most of them, again, is 20 to 30 years, but again, that's with good maintenance. And what we say by good maintenance is not that difficult anymore. We mentioned the Jacobs quite a while ago. That used to be a good performer, and it still is a good performer, but it has very high maintenance. I've seen a bunch of them. They're down just about every week, and you don't want that. The good ones, like the AREs and the Berges, those basically you go up once a year, check that the blades are tight. That's all you really have to do. If you go through a hailstorm like we've gone through, then at some point you might have to go in and take a blade down and get it refiberglassed. But as far as anything else, it's fine. We did that because of the performance more than the durability. I mean, it was fine. It would have stayed together and all that. It wouldn't have broken apart just because it was chipped on the edges. But we wanted the extra performance, made sure it was smooth lines through the blade itself. The small ones are typically gearless. There's just a couple of exceptions to that, but probably most everything you'll ever run into will be the gearless. What we mean by that is there's no transmission, there's no oil in them. It's all permanently lubricated, and the magnets are permanent magnets, so there's nothing that's really moving per se, other than that the outside is moving different than the inside of it. That's what's nice. The new ones in the big are starting to learn from the small ones, from the residential size, and they're starting to make the big turbines. The 200-foot high ones are starting to be made like the little ones now because of that. So that's nice to hear. I think that's comforting for a lot of the residential people to find out that, hey, wait a minute, the big guys are learning from the little guys, so they're starting to make them like the little ones. It's really comforting to know that you rarely have to do anything to them other than just check that the blades are tight. And just the other part of it is, since there's no oil to change, you don't have to worry about that. As far as environmental effects, you should be aware that there are some city regulations to this shadow flicker, what's called. As the blades go around, there's a flicker effect on the shadow. It's similar to, your fingers going around here. You can see the shadow effect on here. That doesn't bother you most of the time, but if it comes through somebody's window, your neighbor's window or your own window, whatever, and you're sitting there at a desk trying to read a paper, it's a strobe effect. And that can actually be very, very detrimental to certain people, that have the medical condition that's affected by that. For the average person, it's still a real bother. It usually only happens a few minutes a day in certain locations, and it depends on the time of year and all that. But just be aware that that can be an issue. And some cities have regulations on that. They actually require you to track where that shadow flicker would be and then show them it doesn't bother somebody. The smaller ones don't typically have any radio interference or TV interference. It's usually the large turbines, because of the size of the blades. They literally become reflectors. The small ones are pretty much all carbon fiber made or fiberglass, and so therefore they don't act like a big metal shield and reflector. So you shouldn't have too much trouble with that. They really have pretty much minimum effects on wildlife, even though you've heard some horror stories on that probably at some point. The stories are always that they kill birds and that kind of thing. We've actually seen studies that show the difference in the levels. And on scale, turbine is a 1, buildings and cars is 5,000. So, and somewhere cats are somewhere in between, like 3,000. So there's very few birds that have been identified as being killed from the turbines themselves in the spectrum of the whole industry. And that's basically what we're saying with that. As far as the grid or battery tied, you have a choice there. Smaller turbines, typically less than 10 kilowatt, that's what you'll use for residential. It might be 1 kilowatt, it might be 2.5, might be 5. There's 3 kilowatt ones out there too. Anything 10 or less, typically you have a choice. You can make it grid connected, so it's straight to the grid. You're just net metering back and forth. If you have extra power, you feed on the grid. If you're short power, you buy from the grid, and the meter shows the difference. You do have another option to go with a battery system too. The nice thing about the battery system is if the grid is down, you still can have power. If you're tied straight to the grid, if the grid's down, then you're down. We got an email here a couple weeks ago from a fellow that's got a 10 kW Bergie, and he thought he answered all his questions by putting that up there. Well, he went straight grid tie. And then last year they had an ice storm and they were out of power for 5 days, the grid was. And because he's straight grid tied, then he's out of power. It doesn't make any difference. He's asking if he can transfer that over to a solar PV system, photovoltaic, which is electric power too. And well, the answer is yes, but he's got to buy another inverter, because the inverter that comes with the one to make it grid tie is not being able to be used secondary. You can't use it twice, so to speak. It's only used once. So be aware of that. If you want to go straight grid tie, that's fine, but you're going to be out of power if the grid's out. If you go the battery version, then you can have your own power, but then you've got to maintain the batteries or get the sealed ones, which cost more. That's another option. It's nice to have the batteries. In most cases, that's what we do, just because people are trying to supplement their system and also have power when the grid is down. So that gives you that chance to do that. There is some loss with the batteries, but it's not that significant anymore like it used to be. This is an example of the Outback system. Xantrex makes some good inverters there too. The Outback is best for the battery because it really knows how to handle the battery better. Xantrex typically, the larger Xantrexes anyway, as well as some other companies, there's Magnatech and other ones, they are typically more for the grid connect than the battery. Some of them won't even have an option for the battery connect. The way the system's set up, again, it will buy power if you need it. Anything over 10K, you start to get into this has to be grid connect. And if you have a